Stan Gibilisco here. I'm going to show you just very quickly what a frequency modulated radio frequency wave looks like on an oscilloscope and how it differs from an amplitude modulated wave. What I'm showing here is a graph of the instantaneous amplitude or signal strength, both positive and negative, as a function of time as it goes by, probably in microseconds or milliseconds in a case like this. But if you look at the wave, you'll notice that I've done my best to show that the amplitude, both positive and negative, is constant. The positive and the negative amplitude peaks are equal and opposite and constant. So the signal strength never changes. Any amplifier through which this signal passes has to work at a 100% duty cycle because it's basically working as hard as it can all the time. But what varies is not the signal amplitude, but the signal frequency or wavelength or period, which you can clearly see as a slower period or a lower frequency around here, then a shorter period and a higher frequency around here, then slow period and low frequency here. This is probably an alternating pair of tones like do, 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 do. But the amplitude of the signal is constant. That is what differentiates frequency modulation from any other type of modulation. Actually, frequency and phase modulation are very similar, and they look very similar on an oscilloscope, but technically they are different in nature. So you can convey information in a lot of ways on a carrier wave, and one of them is to vary the frequency. Do, 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 do. That's a new version of the one that you heard in the movie, right? You know what I'm talking about if you've seen the movie. If you haven't seen the movie, you probably don't have a clue as to what I'm talking about, and I'm sure it doesn't matter anyway. What matters is that you understand that in a frequency modulated signal, the signal strength never changes, even though it looks like it changes a little here. I'm just an imperfect diagram drawer. But the wavelength or frequency or period is what varies and what conveys the information so that there some kind of meaning can be derived from the signal rather than just an unmodulated carrier, which would sound in any receiver like nothing at all. Stan Gibilisco signing off. Until next time, so long.